Okay, chapter 3 is about the structure and stereochemistry of alkanes. All right, remember alkanes is a type of hydrocarbon, meaning hydrocarbons are little carbon and hydrogen atoms. And this particular chapter is going to be about alkanes, where everything is a single bond. All right, alkanes have, and what we're talking about now are straight chain alkanes. We're not talking about cyclical alkanes, just completely straight chain. They have a general formula of however many carbons you have, the number of hydrogens is always, you can calculate it by 2n plus 2, where n is your number of carbons. So for example, let's say you have something, let's say you have like C3, that will have H8. They'll have 8 hydrogens on it. All right, so just to draw it out, just to prove it to you, doesn't matter if it's a straight chain, notice we have the 3 carbons, and 3 and 2 is 5, plus another 3 is 8 hydrogens. That will always be the formula. Alkanes, hydrocarbons, are found pretty much in everything from natural gas to some sort of petroleum product, natural gas, as well as propane and butane in our barbecue tanks, octane in cars, and then once you get much higher up, you get more into the lubricants as well as Vaseline, also candles, pretty much that like waxy material. Smaller alkanes have very low boiling points, and they are a gas. Usually by the time you get to past butane, which is 4 carbons, so like on pentane is probably the first liquid hydrocarbon that you actually get. Here you can kind of see the boiling points of the CH4 is methane. We're going to learn how to name these things. And just to kind of give you a head start, anything that ends in ane is an alkane. That's where they get the name from. So we're going to learn the prefixes, the names of all the prefixes. 2 carbons is ethane, and 3 carbons is propane. This is the chemical formula for propane. All right, here are just a bunch of examples. So again, there's methane, ethane, propane. Those are the structures. Butane. All right, isobutane is just kind of a different structural formula for butane. So rather than having the 4 carbons in a row, you have 3 carbons, and then the 4th one is on the second carbon. So it's like they took this carbon and they attached it over here and took that hydrogen and put it there. All right, and there's pentane, which is 5 carbons. This is just kind of a shorthand of drawing it. I've never seen it with the 2 hydrogens like this, but there's all different ways of doing it. And then isopentane and neopentane, these are just kind of different structures. It's called constitutional isomers. We will talk about it in this chapter. And then these names are what's called common names. We will talk a little bit about common names, but we're going to learn other ways of naming hydrocarbons. All right, here are smaller alkanes: methane, ethane, propane, butane. Here's some physical properties and the names of straight chain alkanes. I am just going to worry about the top 10, or that's what we're going to worry about, are the top 10. We're going to talk about the first 10 alkanes as far as their names and their prefixes. Okay, so these are the names of just the first 10 straight chain alkanes. All right, now this is kind of hard to see, but for something that has 1 carbon, okay, meth is the prefix, and I'm going to take this time to actually talk about the prefixes. So meth, or a methyl group, methyl, YL. These are names that I want you to kind of like know and like memorize. Now, if it's a 1 carbon that has all hydrogens, it's called methane because it's an alkane. If there was an alcohol on this, so if it was like, if one of these H's was an OH, then it's an alcohol, then the name of it is methanol. Okay, if it was an all right. So basically, the meth part implies a 1 carbon fragment, or a 1 carbon, or a molecule that has 1 carbon. All right. So I want you to start memorizing the top 10. So you have meth. The second one is eth, or an ethyl group. This YL, N and IL, YL, we'll talk about that when we start naming, more about naming. So meth, F, prop, all right, and then propyl. Again, I'm not going to write that, I don't have enough room. Bute, pent, hex, hept. Hept implies, so we have 7, 6, 5, 4, 3, 2, 1. Oct for octane, for octane. So octane obviously has 8 carbons. Non or known, I think it's pronounced known, but you can say non too, for 9, and dec for 10. So it's the first 10. Now if you look at 11, it's undec. All right, I believe this is Latin. So undec meaning 1, so it's 10 and 1 more. Dodec, 10 plus 1 more. Tridec, tetradec, pentadec, hexadec, heptadec, octadec, nonadec. All right, it's not hard to know like 19, and then you're 20, it gets a little weird again. It's going to Latin, but we're not going to worry about these. We're really going to worry about the 10 carbon chain. Okay, so if you have a 10 carbon alkane, so a CH3 followed by CH2, 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 all up to 10, that is called decane. Okay, so memorize these prefixes. Okay, it's not too hard. I would say after pentane these are pretty obvious, because everyone's always learned these kind of Latin prefixes at one point. So like the Pentagon is a 5-sided building. Pent, hex, usually people know. Hept. Some people know 7 as sept. Okay, it's not sept, it's hept. It's with an H. Oct, octopus. All right, and 10, like a decade. All right, so it's just meth, F, prop, bute. All right, so know these prefixes, because these prefixes are going to help us with all the naming throughout the whole semester. It doesn't matter what functional group that we are doing. Sorry about that. Okay, butane. This is the structure of butane. Now, the reason they put this N-butane here, you'll see this N a lot. That just means normal, implying it's a straight chain. All right. The reason is because butane has something called an isomer, constitutional isomer, where you can draw still butane. It's still 4 carbons. Notice it's 4 carbons, 1, 2, 3, 4. So it's the bute part of it. But it's an isomer of butane. Isomer is same formula but different structure. We will get to that in a second. So butane, I usually just call it butane. If it's butane, it's butane. I don't use the N, but you will see that N quite a bit. So I just call this butane, 4 in a row. But this is a common name. This is not actually what's called the IUPAC name of how you name things, which we will do in this chapter as well. But when we start talking about common names, you've already seen an example of one. This is just something that's used so often, and it's very common, and they already have a name for it prior of these rules coming out, so that's why they call it isobutane. Right? So constitutional isomers are compounds with the same molecular formula, but carbons are connected differently. All right, notice this is C4H10, and this is C4H10. But they are not the same compound, different compound. Atoms are connected in a different place. So that's what constitutional isomers. All right. Pentanes, all different types of pentanes. So this would be technically N-pentane, right? It's in it's in a normal chain. That's what the N means. And then we have isopentane. It's a different isomer. And then we even have a different isomer they call neopentane. I don't want you to really know these names, these common names. I'm going to teach you a different way of how to name them. It's called the IUPAC way of naming them, which we'll talk about in a second. But just to kind of, again, these are so common that this is the names that they have given them. But the point is that these are constitutional isomers of each other. They all have C5H10 in their formula. Okay, let's get back to, now let's talk about the IUPAC and the systematic names. IUPAC stands for International Union of Pure and Applied Chemistry. This is a group, an international group. So it's from scientists from all around the world, and they get together, I don't know, every so often and have meetings. And in their meetings, they get together and talk about how they can standardize certain things in chemistry. And one thing they did back in the 1800s, I think that was the first time that they met in the late 1800s, they wanted to standardize naming, how to name things, because when you would read a research paper, let's say someone in the United States read a research paper from Japan, they would have a different way of how they name their compounds than like someone in the United States and someone in Europe, a European country, or someone in Australia. You know, they would all have a different way of how to name things and how they write things. So they wanted to kind of standardize it so everybody in the world used the same exact system. All right. So, like I said here, it's a standard method used intentionally to name compounds. And what they've come up with is you use the longest chain of carbons as your main chain. And then common names are kept the same. So like isopentane, those are the common names. All right, so let's talk about the rules. And this is how you're going to start to need to name things. Now, for those of you that did take Chem 112 at Front Range, I believe the very last chapter you learn how to name alkanes. So you might have already had this, which is great. If you did not get this in your 112 class, and obviously you will get it now, but some people do or have had this already. The first rule is to find the longest continuous chain of carbon atoms and use the name of this chain as the base name of the compound. Okay, so if your chain, you know, let's say I have a long chain here, and then I have like another carbon hanging off here and another one hanging off here, your main chain is this longest chain. Okay, so it's 1, 2, 3, 4, 5, 6, 7, the 8 carbons. So the base name is going to be octane because the base of it is the 8 carbons. And then I'm going to have to name these groups that are hanging off of the chain separately. Okay, now your longest chain might not necessarily be in a straight line like that. So let me just give you some examples. Let's say we have this as a compound. All right, it looks like that's my main chain and I have this hanging off. Well, that's not true. You have to look for your longest continuous chain. So my longest chain is right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That, my 12 carbon chain. Now that won't happen because I just told you that you don't have to worry about 12, but this is just an example. And then these 2 carbons, that's supposed to be 2 carbons. This is kind of sloppy here. You know what, let's just redo this one so we don't have a 12 one. So there we go. Now it's better. So here we have a 1, 2, 3, 4, 5, 6, 7, 8, 9. Or we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is my longest continuous chain. Those 10 carbons. That's my longest chain. And then this 3 carbon fragment is hanging off, or it's called a substituent. Substituent. There we go. That's a substituent. Substituents are groups hanging off of my longest continuous chain. So this is some sort of an octane, okay? And this substituent is 3 carbons, which is a prop. Remember, 3 carbons is prop. In this case, this is called a propyl group, okay? So the name of this, again, I haven't told you all the rules. I'm just kind of giving you a head start. Don't worry about how I got this. But pretty much how you're going to name this is this is called 5-propyl octane. We will talk about numbering. I think it's on this slide. 5-propyl octane. Because I have a propyl group, it's on the 5th carbon of the chain. I'm actually start counting here. 1, 2, 3, 4, 5. All right, propyl, and it's an octane. All right, next rule, number. So here's where the numbering part of it is going to come in. Number the longest chain, beginning with the end of the chain nearest the substituent. This is why I get 5 on this carbon, because if I start here, it's 1, 2, 3, 4, 5, 6. Okay, so if I count this way, 1, 2, 3, 4, 5, 6, the 6th carbon has my propyl group. If I start counting on this side, it's the 5th carbon that has the propyl group. So I want to count the side that gives me the smallest number for the first substituent, or the nearest substituent on my chain. Okay, if I have more than one substituent on my chain, I got to figure out which one is closer. All right, again, I'll show you practice problems, and we'll do a lot of practice in class. Name the groups attached to the longest chain as alkyl groups, like what I just did. Alkyl implies YL. Notice alkyl ends in YL, this propyl ends in YL. Give the location of each alkyl group. I did 5-propyl by the number on the main chain. carbon in which it is attached. All right, and then write the alkyl groups in alphabetical order regardless of the position of the chain. That's if I have more than one alkyl group. When I name it, I can name them alphabetically. It doesn't matter which group is first. Okay, so these are most of the rules. There are little rules here and there that you kind of learn along the way, but these are the main ones that you'll see in every single problem. Okay, so let's look at some a practice problem. All right, so sorry. So here we go. First, find the longest continuous chain. In this one, notice the longest chain is not the straight chain; it's curved. Okay, so it's going to be here because it's 1, 2, 3, 4, 5, 6, opposed to 1, 2, 3, 4, 5, or 1, 2, 3, 4. Those are all the possible continuous chains. 6 is the most. Okay, now notice I have a substituent. Okay, now the substituent is closer to this carbon opposed to being closer to this carbon. All right, so I'm going to start counting from this carbon. 1, 2, 3. So the methyl group, this is methyl because it's a 1 carbon fragment. Methyl is on the 3rd carbon. So it's 3-methyl hexane. That is how you name it.